Hi, welcome to this third episode of the Cashscript tutorial series. Today we're gonna write a more advanced Bitcoin Cash smart contract using oracles to get access to price data inside our smart contract. The contract example is called HodlVault and actually comes from the Cashscript website. So if you go to the cashscript.org website, where all the documentation is, and you go under the language description menu item, you find this examples page. And there's a link to a GitHub repository with a bunch of great Cashscript smart contracts. The transfer with timeout contract we already discussed in the first two tutorials, and today we're gonna write the HodlVault contract with Oracle data from scratch. So as the name suggests, the idea behind the contract is that you lock up your funds, and, forcing yourself to hodl until a certain price target has been reached. For example, if you start a HodlVault contract at blockHeight 700,000 with a price target of $1,000, you would only be able to move your funds to, for example, sell them on an exchange if you have a message from an oracle with a matching signature saying the block height is above 700,000 and the price is above your target of $1,000. So indeed, as the description here says, there is a degree of trust in the oracle. But if you use a live production oracle, the incentive to attack your specific smart contract is not that big. So you can already see the finished code right here, but we'll write it from scratch in the Cashscript playground and also invoke the spending function with mock oracle data and actually make a testnet transaction using this. So let's get started on the Cashscript playground. We can get rid of all the example code and start a new contract called HodlVault with one spending function. We'll just call this spend. And then we need to think about the contract arguments and the spending function arguments. So just as in the transfer with timeout case, we don't want anybody to be able to spend our funds or spend the funds of the person who initiated the contract. We only want the owner to be able to spend from the contract, so your funds cannot be stolen. So you need a public key when initiating the contract, and then spending from the contract you would need a matching signature. So first we need a type called pubkey. We will call this owner pubkey, and then in the spending function we need a matching signature, so of the type sig. And we'll call this owner sig to illustrate that it should match the owner public key. And then for the oracle, we also need to provide a public key in advance, so of the same type, pubkey, and we'll call this oracle pubkey. But then the signature is a little different, because this type of regular signature signs the transaction, but the oracle shouldn't sign the transaction. It should just sign the oracle message. So this type of signature is called a data signature. So this is a new type, data sig, and we'll call this oracle signature, oracle sig. And then we should of course also provide the oracle message. So this is of the type called bytes, and we'll call this oracle message. So this is all we need for the spending function, but we still need to provide two extra arguments when initiating the contract, namely the minimum block height and the price target. So both of these are just numbers, so it should be of the type integer. So first let's specify the type int and call this minimum block height, and then a second integer called price target. So these are all the arguments we need, and now we can start writing the require functions. So first of all, we'll write a require statement saying that the signature of the owner should match the public key of the owner. So let's write require and then a signature check, so check sig, and then the two arguments. So first the owner signature and then the owner public key, and with a semicolon at the end. And we should do something similar for the oracle. So, but because this is a data signature, we need to provide three arguments. So we write require, and then not check signature, but check data signature, and then with 3 arguments. First the signature, so this is called Oracle sig, then the Oracle message, so Oracle message, and then third the Oracle public key. If you don't know this order by heart, you can of course always check the documentation on the Cashscript page. This should be lowercase, and of course with a semicolon at the end. So now we know that the person trying to spend from this contract is actually the person who initiated the contract, and we know that the Oracle signature and Oracle message provided match the Oracle public key. So now we need to parse the Oracle message to actually see what it says. And for our mock Oracle, the message looks like this. So first 4 bytes of blockHeight information, and then concatenated together with 4 bytes of price data. So the message of the Oracle is 8 bytes in total, but for a live production Oracle, this would be maybe something more advanced. For example, General Protocols of Bitcoin Cash has described Oracle specification for their price Oracle, and they also include price and block height in their message, but their message is 50 bytes long, so also includes additional information, so parsing it would be a little bit different. When their Oracle is live again, I'll make a tutorial using a live production Oracle, so you can actually don't have to be your own Oracle, but can use a more trusted and reliable source. So let's continue with this. So to get access to these block height and this price data from the Oracle message, we need to parse it. So we'll do this by declaring a new variable. And if we parse the Oracle message of type bytes, this new type will also be a bytes value. So let's first do bytes block height. And this will be equal to some part of the Oracle message. And then we'll do the same for the price. Okay, so we need to parse this Oracle message. We do this by calling the .split function on it, and we want to split it after 4 bytes. So the first 4 bytes and then the second 4 bytes. So split 4, and then we need to provide an index. So do we want the first part of the structured message, or do we want the second part? So this is index 0, this is index 1. So for the block height, we want the 0th indexed part. So we write .split 4 and then between square brackets 0. And we'll do something similar for the price. So split at byte 4, but then we want the second part, so index 1. And now we want to place require statements, 2 more require statements, one for the block height, one for the price. So we'll do this by writing require and then saying the block height should be at least the minimum block height, and then a semicolon at the end. And for the price, the same, require that the price of the Oracle is at least as big as the price target. But if you think about this, you can see that the compilation will fail, but we'll try anyways. We'll do compile, and it says cannot apply operator and then this inequality check to types bytes and int at line 18. And so this is about this line, but also about line 20. So because this is of type bytes, this is of type integer, it cannot do the inequality check. So we should either do the type conversion here or above when declaring the variable. So let's do this above by declaring this as an integer here. So we should do a type conversion here. So we'll write integer, and then between brackets we put the bytes information. So the bytes get converted to a type integer, and we'll do the same for the price part of the Oracle message. And if you press compile now, we'll see that we can fill in the contract parameters, and that's the second step. So that's what we'll do right now. So first we need the public key for the owner. This is something we can just copy paste from the wallet view. So public key owner, copy paste. And then we need a public key for the Oracle. I generated a key pair for the Oracle with custom software. I'll put a link to it in the description, and I'll also just put the public key, the signature, and the message also in the description, so you can copy paste from there. So let me get it from the notepad. The public key of the Oracle is this long string. Then the minimum block height for testnet should be something like 1,400,000, like this. And then the price target, for example, $300 per Bitcoin Cash. So if we press create, we'll see this smart contract, which is already funded with some testnet satoshis. And then we see one spending function, which is what we expected. So if we fill in these parameters, we should be able to spend these 10,000 satoshis from the smart contract. So we need to provide a signature from the owner, matching this owner public key. So we can just select a wallet. But for the data signature, this is not that simple because we generated the Oracle signature and the Oracle message with custom software. So I'll copy paste the Oracle signature and Oracle message from the notepad. So first the Oracle signature, this long hexadecimal, and then the Oracle message. So the Oracle message is 8 bytes, first 4 bytes of block height, and then 4 bytes of price data. But because this is in hexadecimals, you'll see that this string is 16 characters long. And then we need to provide an output. So let's just send to this testnet address, copy paste it with the prefix. And then, for example, send 9,000 satoshis to it. And I will try and hit send. So this transaction would fail or succeed depending on what this actual Oracle message says. And this Oracle message I generated myself just says the same as we provided here. So a value, a block height of 1,400,000 and a price of $300 per Bitcoin Cash. So because of our inequality checks, it says at least or equal to. So our transaction should succeed. So let's see if it does by pressing send and waiting 1 second. And then we should get a notification, and indeed it says transaction successfully sent, and then a link to the testnet explorer. So we can copy paste this if you want to see the transaction on testnet. And then I also funded another contract with a price target of 500,000. A price target of $500 per Bitcoin Cash. So if I press create, you'll see this also funded, and we can leave all the information. But now this transaction should not succeed because this Oracle message only published a price of $300 per Bitcoin Cash. So our price target has not been reached. So this require statement fails. So the variable we generated, price, from the Oracle message does not pass this inequality check. So it's not bigger than the price target. So let's actually check this by pressing send. And let's see if, and then we get a transaction failed with reason, script failed an op verify operation, and then something to debug our transaction with. So that's it for this tutorial. So we successfully made use of an Oracle using the data signature type and data signature check, which is unique to Bitcoin Cash. So you would not be able to do this with Bitcoin or with any of the other forks like Litecoin or Dogecoin. So this is something that was added to Bitcoin Cash specifically, and it's very useful for making smart contracts. Thanks for checking out this episode, and see you in the next one. Bye.